Welcome to part 2. We're going to be doing questions 7 through 12 in this video, covering another fourth of this very nice Geometry Common Core August 2015 exam. That's a mouthful. So let's take a look at number 7. This should be one of the most straightforward questions that you get hit with. You should say when you see a question like this, like, hot damn, this is going to be nice. So let's take a look at this one. For this guy, there's a series of transformations taking place. So first, let's just put down the note. We know that this is a level 1 question. This is from transformations. Okay. And once again, it's just asking us the different kinds of transformations. So let's look at this. Now, over here is our first transformation, and then we have our second transformation. Now, the first one, some people may be like, oh, it's a translation. It just slid down. Nope. This is actually a reflection. And the reason we know this is a reflection is because if you look here, A flips over, right? And if you see a flip, that is a reflection every time. So the first one's a reflection, and the second one is clearly a rotation. Now, if you really want to get fancy about this, and I do like getting fancy, the first one is a reflection over the x-axis, right? And the second one's a rotation of 90 degrees counterclockwise around the origin. But that's getting fancy. It's just asking us for the basic ones. So we could say that the answer is clearly number 1. Peace out. Done. Easy. Love it. All right. Number 2, or number 8, I guess is the right way. In the diagram below of parallelogram, ooh, that's good. We know that parallelogram FED shown below, ED is extended to A, and AF is drawn such that AF is congruent to DF. You know, whenever we get this kind of information, we want to mark it down. Always mark, right? We always want to do marking of everything. Always mark givens. All right, so if you see here, this is talking about parallelograms and filling in angles. So this is a level 5 question. You know what? I'm going to do this in black. I like the black. So level 5, that's where you learned about parallelograms. And there's 2 possible things that are going to help you with this one, okay? There's 5 properties of parallelogram, okay? And 2 will help you out in this one. But let's write down the 5 properties just to remind ourselves, okay? 1, opposite sides are parallel. That's one property. 2, opposite sides are congruent. 3, opposite angles are congruent. 4, opposite, that's not even what I was looking for. Consecutive angles are supplementary. And then finally, 5, the diagonals bisect each other. All right? Bisect each other. Do we need all of this information for this question? No, but it's good to review the properties whenever we can. So it tells you that R is 124, which goes right here, and we're looking for this angle right here, angle AFD. The first property I'm going to use to solve here is that opposite angles are congruent. So R is going to be congruent to this angle right here. These are opposite angles, so they are congruent. The second property I'm going to use, well, I guess it's not a parallelogram property, is that we have a linear pair right here. These 2 angles make 180 degrees. So I could just do 180 minus, that doesn't look like 180, minus 124, and that's going to give me 56 degrees. Good. Now, since this is an isosceles triangle right over here, we know angle and angle are congruent. Those are my base angles, so this is also 56 degrees. And then finally, we can use the triangle sum theorem to get our missing angle right over here. So we do 180 minus the 2 base angles, and we get 68 degrees. Nicely done, guys. Sweet. And as I should say, you should be doing these on your own first and then checking your answers. All right, number 9. Woo-wee. If x squared plus 4x plus y squared minus 6y minus 12 is equal to 0 is the equation of a circle, the length of the radius is what? All right, so first of all, what level is this from? Well, circles, this is level 9. Equation circles, all right? And just remember this, the general equation of a circle where we could see the center and radius is going to be in this form. x minus h squared plus y minus k squared is equal to r squared. Now we're just going to do the math on this one. Remember, we got to do some completing the square here. So let's go for it, okay? So we got x squared plus 4x plus blank plus y squared minus 6y equals, and I'm just going to tell you this, I'm going to add 12 to the other side. All right, you want to get the numbers on the other side. All right, equals 12. Oh, and I don't have enough room to write all this. Let me, just bear with me. Let's write these out again. So x squared plus 4x plus blank plus y squared minus 6y plus blank equals 12, and then I'm going to add the two blanks. Remember, if I add it to one side, I got to add it to the other. Now to get the blanks, we're going to complete the square. And what you do is you take your numbers, divide them by 2, and square it. So 4 divided by 2 equals 2. I'm going to square that number. I get 4. So that's what goes right here. In fact, I'll put it as a different color to make it super clear. Okay? And then my second one, I do negative 6 divided by 2 equals negative 3 squared, and that is equal to 9. I'm going to put that in another color too. All right, and since I add 4 and 9 to one side, I'll add them to the other side. Now, we can just factor these down. This is x plus 2 squared. That's just half of this. That's what goes here. Plus y minus 3 squared. That's just half of this. Is equal to 12 plus 4 plus 9 equals 25. So my answer is 25, right? No, don't get tricked here. Remember, it's your center of this one is going to be negative 2, positive 3. You switch the signs, and your radius is equal to the square root of whatever you see there, and that is 5. Sweet. All right. You copy that down. I got to erase all this to make some room. All right. Next question. Love doing Regents. Love these questions, so fun. All right, given an mn below with m at negative 6, 1 and n at 3, negative 6, what is the equation of the line that passes through P, which is 6, 1, and parallel to mn? Easy. Love this question. Well, this is from level 7, coordinate geometry. Coordinate geo. All right. And you might remember this. We actually have to make the equation of a line, so we're always going to write down this y equals mx plus b. This is when we're writing the equation of a line. If I see write the equation of a line, I'm writing y equals mx plus b and mxy. All right? Well, my x and y are always the point that passes through, which in this case are, well, 6 and 1. So we got 6 for x and 1 for y. But I got to figure out my slope. And I know my slope is going to be the same as mn because we're looking for the parallel line. So we got to find the slope of mn. Easy. We'll just count it. 1, 2, 3, 4, 5, 6. So it's down 6. Remember, you always count left to right, and then over 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's over 9. My slope is negative 6 over 9. We always reduce that to negative 2 over 3. Sweet. Now we can just plug it in. We get y is equal to y. Come on. We got to solve for b here. Let's get real. It's 1 is equal to negative 2/3. X is 6 plus b. 1 is equal to negative 4 plus b, add 4 to both sides, and I get 5 is equal to b. Final equation, we're going to use the slope, we're going to use our y-intercept. Y is equal to negative 2/3 x plus 5. It is parallel, and it'll go through the point P. You could even check me on that one, all right? So if we start at 5, and we go down 2 over 3, down 2 over 3, those are our 2 points. Oh, look at that. We got a parallel line that goes through point P. You could have also just plugged in, tried graphing all the answers. That'd be another way to do it. Or you could have just said like, hey, the slope has to be negative 2/3 and the y-intercept has to be positive if it goes through P. But our answer is number 1. Sweet. All right, let's move on down. All right. Linda is designing a circular piece of stained glass with a diameter of 7 inches. She's going to sketch a square inside the circular region. To the nearest tenth of an inch, the largest possible length of the side of the square is what? All right. Well, first of all, This is actually, oddly enough, a level, I'd say it's a level 9-ish question on circles because circles are involved, but it's kind of different. It says you got a circle here, right, with a diameter of 7 inches, and so we know this is 7, right? And we also know that we got to sketch a square inside, like so, all right? What is the largest possible length of one of the sides of the square? Now, this is the thinking part, and this is a difficult question. What you should do is actually draw the diameter, all right? So this is the diameter. It also has to be the diagonal of the square, which is 7 inches. Now, what we want to do is find one of the side lengths. So that's either this or this, and remember, they're both the same. Now, since this is a square, all the angles are 90 degrees, and so you might be thinking, well, how do I figure out what x is? Well, right here, guess what pops out? Oh yeah, that's a right triangle. And if we want to find the missing sides of a right triangle, all we have to do is do the Pythagorean theorem. If you also want to be really fancy, and I'm going to do it the hard way here, we can use trig. Well, since we know this is a right triangle and the two angles are congruent because that's an isosceles triangle, we know these angles are both 45 degrees. So we could actually do some trig here and figure out what it is. So x is my opposite, 7 is my hypotenuse, right? What we do here is this. Since we have opposite and hypotenuse, we're going to say the sine of 45 degrees is equal to opposite over hypotenuse. We're going to drop a 1 under. We're going to do a little cross multiplication. We get x is equal to 7 times the sine of 45. And we got to put that into the calculator. Now, let me grab my calculator out right now and see what I got. Calculator, I love you. Sine, oh, no, let's get here. Taking the sine of 45, multiplying that by 7, and I get 4.9. And that is my answer. Nice. Now, you could use the Pythagorean theorem. You could have done x squared plus x squared is equal to 7 squared. You get the same answer. 2x squared is equal to 49. X squared is equal to, well, 49 divided by 2 is 24.5. Square root of 24.5 is also 4.9. Wow, that always works. Sweet. Very useful. All right, last question. Moving on down, moving on down. Oh, go like that. Okay, ooh, this is a fun one. In the diagram below, we know AC is tangent to circle O at A and to P at C. OP intersects AC at B, and OA is 4, AB is 5, and PC is 10. What is the length of BC? So what we're looking at here is actually similar triangles. How do I know that? Well, first of all, we have congruent angles here, okay, because those are vertical angles. And then we both know that tangents, when a line is tangent to a circle and intersects the radius, we get actually a 90-degree angle. So this is angle-angle similarity. So this is a level 9 question. Sorry, not level 9, level 4 question. Nope, not level 4. That's a lie. Level 3. I designed this stuff. I should know this. That's a similarity question. All right. Now, if we want to find the length of BC, we're going to put an x over here. And then we just got to set up our ratios. So, since we have angle-angle similarity, we know the sides are proportional. We're just going to do 10 is to 4, remember bigger over smaller, as x is to 5. We know this because 10 relates to 4, x relates to 5. We're going to cross multiply. We get 50 is equal to 4x. X is equal to, divide both sides by 4, and you get 12.5. Dope. So BC is 12.5. All right, guys, that's it for this video. Meet you on the next one for questions 13 through 18.